Okay, review video number 1. So this will be 1, 4, 7, 10, ... the third period video. Obviously, click the other links for the fourth and sixth period video to catch the other multiples of 3. Or every other third. You know what I mean, every third one. Number 1, f and g are twice differentiable. H of x is f of g of x. Then h double prime. Oh, yeah, this is going to be an ugly answer. In fact, I think I mentioned this to some classes yesterday. A shortcut on derivatives is, if you're not sure, just pick the longest one. Is probably it. Don't do that. But if you absolutely are stuck somewhere, it's not a bad strategy. Okay, so h prime of x will be f prime of g of x times g prime of x. That's the chain rule. Okay, except now I want the second derivative, so now I'm going to have to be really careful here about using the product rule. And since I've already got f's and g's, I should be real careful. I don't want to write the product rule as fg prime plus gf prime, because that's really going to mess me up when I've got f's and g's and primes already here. So I'm going to just say it's first times derivative of the second plus second times derivative of the first. I'm trying to keep track of this without losing my mind on this one. So the first one is f prime of g of x. Derivative of the second would be the second derivative of x. Then the second function is g prime. The derivative of the first function, okay, outside in, chain rule again. So the second derivative, but leave the inside alone, and then times the derivative of the inside, so g prime of x. So that is a mess. I do see that I have g prime times g prime, so that's a g prime squared. So that maybe is a g prime squared f double prime g of x plus f prime of g of x times g double prime. It was the longest one. Again, I don't know that that's the foolproof way to go, but clearly C and D, that not enough was done on those. So picking the longest is, last resort. If you got to do something, it's, I guess, a decent enough rule, or guess anyway. Number 4, which of the following limits are equal to 0? Okay, they're all going to infinity, so I can use the top no, bottom O equal co thing, or I can just think about who's bigger, which leads to top no, bottom O equal co. So the first one, the biggest terms are the x squareds, so that's eventually going to reduce to 5/3. So that's not equal to 0. In the second one, 5x cubed in the top, 3x to the fourth in the bottom. Well, x to the fourth is definitely bigger than x cubed. So remember, this is like levels of infinity here. That's infinity cubed, but this is infinity fourth. So this is headed towards 0. And number 3 is kind of the opposite problem. X squared in the top is like big infinity. 3x in the bottom is infinity, but not that big of an infinity. So this is headed off to infinity. So only number 2. We could have used the L'Hopital rule on those, but it's just easier to do top no, bottom O equal co. A little side note here, we're not doing 5 in this video, but horizontal asymptotes, that's the same thing as limit as x goes to infinity. So number 5 is kind of the same question as number 4, just worded differently. 147. F prime at 1. Okay, derivative at 1. This looks like a quotient rule problem. So I'm going to quotient rule in place here, because I know I start at the bottom. That's kind of the key. Start at the bottom, work your way up. Or keep the girlfriend first, gf prime. So 3x minus 2, f prime is 4x minus the other way around, so minus fg prime, 2x squared plus 3 times 3 all over 3x minus 2 squared. Then I guess I have a choice. There's algebra to do, or I can plug in 1. I think most people are going to choose to plug in 1 first and hope that some of the algebra becomes unnecessary or takes care of itself. So if I plug in 1, 3 minus 2 is 1 times 4 minus 2 plus 3 is 5 times 3 all over 1 squared. So 4 minus 15 is negative 11. Main point of that one was quotient rule. Gf prime minus fg prime over g squared. Low d high minus high d low over low squared. Number 10. If g prime is that, what is g double prime? Oh, that's a little bit of a weird way to ask this. Like, they gave me the first derivative and they want a second derivative, so I just need to take one more derivative. But I am going to rewrite this. It's a little bit of algebra here. If I want to take it as it sits there, I can do a quotient rule, but I think it's going to be easier to do algebra first. So 10x to the negative 3. Right, move the negative 2 down, decrease the power by 1. 10 over x cubed. Plug in e, which seems weird, but whatever. Plug in e, we get 10 over e cubed. So answer C. That wasn't really that hard. It's just they gave you a first derivative and asked for a second. That seems weird. And then you plugged in a weird number. Number 13. Graph has, okay, so now we're thinking about things in the bottom. Like, I think I want to factor this thing. Definitely factor the bottom. So something's going on at 2 and negative 2. I probably need to factor the top as well to get the details here. So x plus 3 and x minus 2. So the x minus 2's will cancel. Meaning there's a hole, excuse me, a hole at x equals 2. That's a removable discontinuity. Right, that's a fancy word for a hole, because when you mark it out, you remove it. So I think it's B. Let's check the others. Infinite discontinuity would be a asymptote. There would be one of those at negative 2. So A is out. Horizontal asymptote, I just said a minute ago, that's where x goes to infinity. So this is going to be a top no problem. When x goes to infinity, this thing just blows up, so that's out. And a vertical asymptote at negative 2. So, not 2. That was out. So it is B. Hole and removable discontinuity means the same thing. Number 16. Ugh, yuck. All letters. What is H prime? Okay, so overall big picture is quotient rule, but then when I have to do the derivative of the top, that'll be product rule. So this one might be easier to write as low d high minus high d low over low squared. Okay, so low is W. Derivative of high would be, that's going to be the product rule. So this is a problem that uses quotient and product all in one. So the product rule on UV would be first times derivative of the second plus the other way around, so second times derivative of the first. And then minus high d low. High is UV, d low is W prime, all over W squared. Okay, well A and B are out. Oh, A is especially out. Don't you wish it was that easy? You could just take the derivative of each of the pieces. That's not it. B, I don't know what they did. They did product rule on the top, but then just took the derivative of the bottom, but that's not right. So I got to figure out between C and D. Let's see, goodness. Okay, the only subtracted term is UV W prime, so it's got to be D. I wonder if C is they got the low D high, high D low thing backwards. Once again, the shortcut of just pick the longest one. At least it narrows it down to 2, I guess, for that one. Number 19. Let f be the function defined by square root of the absolute value of x minus 2. Which of the following statements is true? Well, it would be helpful if you knew what this thing looked like. That's the only way, not the only way, that's the best way to answer this question. So if x is 2 or more, then the absolute value bars don't matter. So if x is 2 or more, then it just looks like a good old square root function. Now, if x is less than 2, then we got to be careful here. If x is negative, if x is 1, square root of 1 is 1. If x is, let's come all the way over here to negative 2 to get a nice answer. Then the square root of 4 is 2. And so it's the absolute, or it's the square root thing shooting off the other direction. So I would say it would be very helpful to know the graph of that thing. That way you can answer these questions. Part A, f is continuous but not differentiable. It's definitely continuous. Is it differentiable? Why not?
Because it's the cusp.
The cusp thing. So I think it's A. Let's read our other answer choices. F is differentiable. No, we just said there's a cusp there. F is not continuous. No, it is continuous. Like you can draw the thing without lifting your pencil. So it is continuous. Limit as x approaches 2 is heading to 0. So that one's out. So yes, it is A. Can't have a derivative at a cusp. (22) Which of the following limits is equal to 5? X goes to infinity. That means I can do the top no, bottom O, equal co thing. That one's equal to 5. That's an easy one. Uh-oh. Absolute value of x minus 8 over x minus 8. I don't think we've seen that graph in here. Something's going on at 8. In fact, you can't even use 8, right? Because then you'd be dividing by 0. But I got x minus 8 over x minus 8. If we're a little bit bigger than 8, then the absolute values wouldn't matter. We could cross those out, and we would just have 5. And that doesn't help because I want to approach 8 from the left. So if we're a little less than 8, then those sort of cancel, but the top one's positive because of absolute value. The bottom one would be negative. So it would look like that. So this is a weird graph, but it's a graph that calculus expects you to know because then you can answer all kinds of questions. So as x approaches 8 from the left, that equals negative 5. So that's not it. Yeah, that's right. Number 3, as x approaches 4, from the right, you know what, maybe we can do it without even looking at the graph. Let's just plug in 4.1 and then 4.01 and see what happens. So if I plug in 4.1, I get a positive number in the top, a negative number in the bottom, so that becomes negative 5. 4.01 would be the same thing, like 1 is positive, 1 is negative, so negative 5. So that thing's approaching negative 5. Those are tricky. The absolute value and not absolute value. So they sort of cancel, but you got to be real careful about the sign. Well, without answer choices, I see derivative of tangent. I'm like, oh, I know that. That's secant squared. But then I look at my answer choices and I'm like, wait a minute, that's not the kind of problem it's asking. It wants to know which one of these is the format of the definition of a derivative. So it's not these secant squared ones. And it's f of x plus h minus f of x. So that one's C. H prime at 1. This is tricky because at 1 we're changing functions. We're changing from a cubic to a linear. So I need to check to see, is this thing even continuous? And then I need to check about its derivative. So I need to check the function at 1 and the derivative at 1 on both pieces, yeah, to see that it connects. So this first one will answer me, does it connect? And the second question will be, does it connect smoothly, as in, are their slopes the same, or is it a cusp? So we plug in 1, 4 minus 7 plus 3 is 0, 5 minus 5 is 0. Okay, so they connect, so it's continuous. So that means now we can move to the next question and say, well, what's the derivative of each piece? 12x squared minus 7. And if I plug in 1, I get 5. The derivative of the second piece is just 5. So they match. So that derivative is 5. So they connect, and they connect smoothly with a slope of 5. So I would not hazard a guess of what this thing looks like. But basically what's happening is you've got a cubic left of 1, and then at 1, it not only does it connect, but it connects with matching slopes. So it's a smooth transition. You do have a derivative. Yuck. Although algebra, maybe f prime of x. Well, if we're going with our longer is better, then I'm thinking it's either A or D. Surely it's not B or C, but let's see what happens here. I think I want to algebra this thing first. Meaning, let's write this as natural log of x to the 1/3 minus natural log of e to the x but then the 1/3 can come down front, and the x can come down front for that matter. So 1/3 natural log x minus x ln e, that's just x. I still have an option here. If I take a derivative now, I have to do the product rule on kind of this whole chunk of stuff. I think I'm going to distribute. So 1/3 x ln x minus x squared. So now the derivative. All of that was algebra. So first times derivative of the second plus second times derivative of the first. And then don't forget the derivative of x squared is just 2x. So do any of those match up? Let's see. So 1/3 1 plus ln x minus 2x. Oh, it's a little bit weird, but it's answer A, right? Because if I distributed the 1/3 to the 6, that's where the 2 would come from. So our format looks a little different than theirs, but it's answer A. Which again, fit the pattern of, when in doubt, pick the longest one and hope for the best. 34. Find the derivative. Another one where you could pick the longest one and hope for the best. But I don't know that there's an obvious answer doing that way. I'm going to do algebra again. So split it up using log rules, and then again properties of log. So now I can do dy dx 1 minus the argument in the bottom, 1 over the argument, times the derivative of the argument. So the derivative of the argument in the top, which would be e to the 2x times 2. And that doesn't look like any of my answers, but I guess if I get a common denominator, maybe things would work out. So e to the 2x plus 1 minus 2e to the 2x all over e to the 2x, plus 1. So that would be 1 minus e to the 2x, which is answer B. That question had like 5 algebra steps and 1 little calculus step in there, which is the danger of taking calculus. You get the calculus right, but you also got to get the algebra right. $37. Limit as x goes to 0. Well, first guess is plug in 0. 3 to the 0 minus 2 to the 0 over 0 minus 0. That's 0 over 0. And what is that supposed to trigger in our brain? If we get a limit of 0 over 0, limit, then it's another L word, L'Hopital. Limit L'Hopital. So that means the derivative of the top and the derivative of the bottom. So the derivative of 3 to the x is 3 to the x times natural log 3 minus 2 to the x times natural log 2 all over 2x minus 1. And again, limit as x goes to 0. So 3 to the 0 is 1, 2 to the 0 is 1. So I have natural log of 3 minus natural log of 2 all over negative 1, which doesn't look like any of my answers, but there's a property of log thing going on here. Let's see how to best do this. I'm going to divide them both by negative, so negative natural log 3 plus natural log 2, which means we could combine them with 2 in the top and 3 in the bottom. That's It's another one with a little bit of calculus and a little bit of algebra. Maybe more algebra than calculus. Number 40. Limit as x approaches 2. I'm guessing we're still in the L'Hopital section, but we'll see. So we plug in 2. 4 minus 6 plus 2, that's 0. Plug in 2 in the bottom, I get 2 times 4 minus 4. Oh, that's not a L'Hopital's problem. That one worked out. I just get 0. My guess is if you skip that step and say, oh look, it must be a L'Hopital's problem. 2x minus 3 over 4x. And then you plug in 2, that would get you, let's see, 4 minus 3 is 1 over 8. You get 1/8. Uh-oh, but it's not L'Hopital's because you tell me what unlocks or what triggers L'Hopital.
If it's 0 over 0, infinity over infinity, or negative infinity over infinity.
L'Hopital only for 0 over 0 or some combination of infinities. So be careful. Plug in first. I almost didn't plug in because I was thinking just like, oh, we're in L'Hopital's. Let me just skip that. But glad I didn't. You got to check it first because you can't use L'Hopital unless it's one of those cases. Tricky. Alright, like and subscribe. Don't miss all my other videos. Comment down below with your favorite problem. Stay tuned for more original content from Mr. Wolf's pre-calc class.